Hello everybody, today we're going to be talking about duplicate recessive epistasis. So epistasis is essentially the idea that expression of an allele at one locus will modify or mask the expression of an allele at a second locus. So pretend that this pencil is one chromosome with two alleles on it, the A and the B. So epistasis is the idea that expression of this A allele will modify or change in some way the expression of this B allele. So we're specifically looking into duplicate recessive epistasis. To illustrate this, I'm using the example of my dog Athena, who I drew here. She has heterochromia, which means she has two different colored eyes. So in duplicate recessive epistasis, there are essentially two phenotypes that are possible. If you have a homozygous recessive genotype at either locus, big A, or little b, you'll have the first phenotype, which is blue eyes in this case. Or if you have a dominant allele at both loci, so you have a big A and a big B, then you will have the second phenotype, which is in this case heterochromia. So let's consider a normal dihybrid cross. Under normal circumstances, we would expect to get 4 different phenotypes with a 9:3 to 3:1 ratio. However, with duplicate recessive epistasis, we will only receive 2 phenotypes. Those offspring that have a big A and a big B allele will be heterochromatic, and those that have a homozygous recessive genotype at either locus will have blue eyes. So this will actually result in a 9:7 ratio, with 9 offspring being heterochromatic and 7 having blue eyes. Now let's consider a second example of a cross between a big A, big B parent, and a little a, big B parent. So, as I've shown here, we have a half a chance of the parent passing on a big A allele or a little a allele, and a half a chance of them passing on a little a allele and a little a allele. And for each of these, we have half of a chance of the parent passing on a big B allele and a big B allele, or a big B allele and a little b allele. So multiplying these across, we get a 1/4 chance of each of the 4 genotypes. As far as phenotypes go, 2 out of the 4 will be heterochromatic because they have a dominant allele at both loci. And 2 of the 4 will have blue eyes because they have a homozygous recessive genotype at the A locus. So this would result in a 1-to-1 phenotypic ratio. Here are my references. Thank you for watching.